Hello everyone, this is Public Consulting for Group 7 for the company Delivery Corp. Now, the table of contents for our presentation would be first, the first solution, which will be the forecasting of the demand and first solver solution. Then we'll proceed to question 1 related to the sensitivity of the model. Then we proceed to question 2, which would be the adding cars to the model, and finally to question 3, which is limiting the facility to 1. Day 1, we start with the forecasting of the demand. With the given data, the forecast of demand was calculated first considering all features, then only population, and finally with feature engineering, population, surface area, and shops. We use linear regression to calculate the forecast and then find the best R-square value. The forecasted values are then evaluated on the new sets of value to find the best possible method. We were able to discover, taking into account the R-square, that the population gave the best results in the new set. For day 2, we had to find the hub locations to deliver the zones through bike. We understood the challenges, which were the capacity per bike, average speed, working time, the cost, and delivery time per parcel. Considering these challenges, we tried to work on an optimal solution for reducing the operation costs. First, we calculated the number of bikes required for delivery of the total demand, and with the detour coefficient, we calculated the optimum length in the delivery area for each zone. The distances between different zones and the renting costs of each area zone were considered to get the optimum um, cost using Solver. We ended up with 3 hub locations for meeting the demand. In this slide, we can see that we have three centers, 8, 25, and 41, and each center has assigned different number of areas, 17. With this solution, we end up with a total cost of 13,611, which was a very good cost for us. Day 3, we had to do an what-if analysis to address the problems and challenges. For the first challenge, we chose to change the demand parameter and find the variation in the model we proposed. In this statement, we tried to compute in terms of data for day 1, where we increased the demand by a 10%. Based on our model, it was observed that the results improve the R-square, which will be now 0.97. This is a factor which reasons the forecast to be more precise and accurate. For question 2, the second challenge, we had limitation in the number of bikes for delivery. Therefore, we had to consider an extra transportation for meeting the demands. In this case, cars. Based on the same technique, where we only use bikes, we found the operating cost for using both bike and car. We used Solver to find the main hubs and reduce it down to 2 and divided zones for bike and car, which can be seen in the current slide. Taking into account this restriction of 30 bikes and the possibility of having cars to delivery, we found out a new optimal solution having only 2 centers, 21 and 40, with a total cost of 13,356, which was lower than our previous solution. And now we distributed the demand between car and bike, where car is being shown depending on the hub with the light color, and then the bike is shown in the map with a dark color. For question 3 and final question, we ran the model again, increasing the capacity to the total demand so we could know with the solver where to distribute bikes and cars, only having one distribution center, since we knew that it was not possible to have 2 distribution centers as our optimal solution. We ran our solver using both car and bikes because it was shown that this option reduced the total cost for our model. After doing some research of our own in order to know which could be more feasible and a convenient solution for the missing demand to be fulfilled, we decided up that subcontracting during only the first year will be the best scenario for us. So research, subcontracting is risk adverse. It increases productivity and it has fewer legal obligations. than having to hire or fire people, also the training included. Besides that, it offers more flexibility for the organizations when they require increased productivity and better service levels. In this case, we show the map for the demand with only one distribution center, which will be changed to the zone 28. And then once we're able to build up a new distribution center, we'll change to the same solution as we had in question two. But only during the first year, we'll be proceeding with this map where the car zones will be distributed in blue, and then the bikes will be distributed in green as shown in the map below. Thank you very much for your attention. I hope you enjoyed the presentation. If you have any questions, please let us know and we'll be happy to answer them.